start by building our pipelines. So the first thing that we want to do before we actually push anything is determine what our pipelines should actually look like to best fit our team's needs. Now, our product manager asks us to just get a starting pipeline up and running. So let's start off with the basics. Within our pipeline, we can define 3 different jobs that should be run, which we can define with scripts. Now, there are 3 types of scripts commands that we can run. There is the basic script command, which represents the main logic that should be run for the job. An important aspect is that the exit code of the script defines if the job is considered successful or not. We also have the before script, which, as the name suggests, runs before the script command. Often, this might be leveraged to set up the environment which is needed to run an actual script, for example. This means that it's also concatenated to the actual script and runs in the same shell. And finally, we have the after script. The after script runs after the actual script, which is why it was so cleverly named the after script. It runs in a completely different shell than the before script and the actual script. Its return code also doesn't impact the entire job success or failure status. Now, it's not only important to understand the basics of the scripts and what a before the actual script and what the after script is, but it's also important to understand the order in which these scripts run within a job, and to understand the execution order of those jobs. By default, jobs will always wait for all the jobs in the previous stage to run. So for example, in this here example, we see a test job in the test stage, and this will not run until all the jobs in the build stage are complete. So in our case, this is just going to be the build job. So now we've looked at how a simple job can look like and looked at the execution order of these jobs. Now, an important aspect is also where these jobs are executed, the GitLab runners. GitLab runners allow you to run your jobs, also allowing you to tag certain runners to make sure they only run specific jobs. And although jobs can run for any number of minutes, they're usually picked up within just 5 seconds of them being created. Now, if you're running on AWS, you can even leverage autoscaling. This helps make sure that you always have the correct amount of runners to meet your needs. Now, you can also custom configure your runners to perform the way you need. This includes things like setting the maximum job and script timeout, preventing runners from revealing sensitive information, leveraging runner and job tags to align jobs with specific runners, as just mentioned. You can also define the Git strategy. So for example, if the repository should be cloned or fetched. You can also define custom artifact and cache settings. Now, those are just a few ways in which you can configure your runner, but there are, of course, many, many more ways that you can find in our documentation. Now, another important aspect here is the different types of executors depending on your needs. We offer anything from SSH, shell, VirtualBox, Parallels, Docker, and Docker Autoscaler, which is currently in beta, Docker Machine, Kubernetes, and custom as well. All right. So with that, let's start off with our first hands-on section here, where we go over how to create a simple pipeline. So let's head back over to our group. And we'll go ahead and go into our project, the Tanuki Racing CI workshop. And I will go ahead and open a second window here. The reason for this is on the left-hand side, I will be running the workshop. And on the right-hand side, I'll just have this open to show the instructions. Talking about the instructions, well, you'll find them under Plan and then under Issues. And as mentioned, these are numbered conveniently 1, 2, 3, 4, 5, and 6, and we will start off with number 1, simple pipeline. If you click on this, you'll get all the instructions here. I'll minimize our sidebar here just to make it a little easier to read. And so let's go ahead and get started. So step 1, creating a simple pipeline. So now that we have this project in here on the left-hand side, what we want to do is take a look at the GitLab CI YAML file. So for this, if you are on the project page itself, you'll find this pretty much in the center of the project, .gitlab.ci.yaml file in here. And just go ahead and click on that. Now, what we'll see is we already have a simple pipeline defined here. We have 2 stages, build and test. And we also have a build job in here with a before script. So that's this section, which we just briefly mentioned earlier. We have the actual script, and we have the after script. Now, let's keep going with step 1.3. In the test job, we want to use an after script to echo out that the test has been completed. Now, what we want to do is edit the pipeline, and we'll do this by opening the pipeline editor. Now, the way we do that is go over to the left-hand side, and we go to the build menu item, and then click on pipeline editor. So now we can actually go ahead and edit our pipeline. Now we'll scroll down to the bottom where we see our test job. Now what we'll do is we will copy our after script here. The easiest way to do that is just going over here on the right-hand side and clicking the copy button, and then pasting that in here, making sure that you also have the indentation correct here. Now, all in all, it should look something like this here. If for whatever reason you are stuck or you're having a little bit of issues with the indentation, also just go ahead, copy that. You can just replace the entire test job in here. And sure enough, with that, we add our after script. Now with that, we can go ahead and click commit changes. And this will go ahead and trigger a pipeline. And let's see, to build, no issues were detected in the YAML file. Yep. All right, so we can go ahead and click on commit changes. And sure enough, we already get this validation. Pipeline syntax is correct. And in a second here, we'll see this pipeline being kicked off here. Now, if you are running into any issues, you can always click the validate button here, which basically just takes a look at the current content in the edit tab and simulates this and gives feedback if there are any issues. All right. So under 5, we will want to take a look at our pipeline. And there are a couple of ways of doing this. On the top here, we can always press the View Pipeline button. Alternatively, we'll just go ahead and follow the instructions here and click on Build on the left-hand side, and then click on Pipelines. And here we see that pipeline running. And to click on this, all we do is press this unique ID in here, and that will redirect us here. And so now we can see the build job in the build stage and the test job in the test stage. And if you want to, feel free to click into the test job and follow along and see that script execute at the end of our job. But we'll go ahead and get back to this later on anyway, so you can take a look at it then. And with that, we basically finished step one. Now, the other thing that we'll go ahead and mention is GitLab Duo in step two here. So let's say you do have some additional questions here. Let's say, I don't know, what if we hadn't known where to find our running pipeline, wanted to learn more about the image keyword, and so on and so forth. And so GitLab has a functionality that leverages AI that can help with this. So all we do is click up here on the top right, where we see GitLab Duo Chat, or clicking the help button on the bottom left and looking for the Ask GitLab Duo. Let's see. Sure enough, I actually don't see it in here. I always use the top right. So I'm assuming that should be available at this point in time as well for everyone. So just go ahead and click that. I'll go ahead and clear mine right here. So that reflects what you're all seeing. And now we can ask it various different questions. So for example, what CI/CD keyword can I use in GitLab? And sure enough, GitLab Duo will come up with an answer. And yeah, basically help us understand a potential solution for this. So throughout the workshop also, I mean, obviously we're here to help with our Q&A team. That being said, if you do want to play around with this, or if you want to, yeah, see if you can get an answer from this, feel free to use GitLab Duo Chat in this case. All right, so with that, we are done with our first hands-on section. So let's go ahead and jump into the second section here, where we talk about job execution order and directed acyclic graphs. So just to recap, we got our simple pipeline set up and everyone loves it. We were, however, asked if we could somehow speed things up a bit. To address this, we'll go ahead and create a pipeline with different execution orders, as well as large directed acyclic graphs. So currently, we have jobs that execute in the default order. So first, everything in the build stage, and then everything in the test stage. Now, assume we will add a new test called superfast test, which doesn't really need the result of the build stage. So we could run it in parallel. However, we want to keep it in the test stage as it's still related to testing. Well, we can leverage the needs keyword to do this. Needs allows us to specify which specific jobs we need to run beforehand in order to run this specific job. This is independent of the stage that it's actually in. Now, if we leave it empty, well, that just means that the job doesn't require any prior jobs, and we can just kick it off right away. We can leverage the needs keyword to build highly custom optimized pipelines specific to our needs. With the added complexity comes the potential difficulty of actually understanding how the pipelines function by purely looking at the YAML file. That's why GitLab adds directed acyclic graphs, or DAGs, to help visualize our pipelines and get an understanding of everything going on quickly and easily. One thing to also mention is that you can actually use the needs keyword within the same stage, which was previously not possible and only doable between different stages. This can be useful to make your pipelines more efficient, implicitly configuring the execution order, resulting in faster writes. By improving the efficiency of our pipelines, we directly affect the cycle time. And this is now available for all tiers from version 14.2. So with that, let's go ahead and try that out. Now, if you followed along, you'll be in a similar situation here, and you will still have that first issue open on the right-hand side. So what we'll do is we'll go back. You can either press the back button or again, go to Plan and Issues. And then we'll take a look at the second issue here, execution order and DAGs. Go ahead and click on that. And now here we have the instructions for our second hands-on part. So the first thing that we'll look into is execution order. Now, what we want to do, let's see here, we are coming in from the last track, sure enough, and we should still be on the pipeline page. So that's what we see over here on the left-hand side. Now, what we want to do is go back to our project and click through build pipelines and then click on the hyperlink to get to our most recent pipeline. Yep, so sure enough, we're still on this pipeline. You can see that our pipeline jobs ran sequentially, but what if we wanted 2 jobs to run in parallel? So this we can achieve with our needs keyword. So what we'll do here is we'll head back to our GitLab CI YAML file. Again, easiest way of doing this is going to build and then pipeline editor. And let's see here. Currently, we only have the test job running. And what we want to do is add the super fast test job below the test job. So in this case, we'll scroll down here. We found our test job in here. We'll add our super fast tests job. And now that we have the 2 jobs that we want, so the test job, and as we can see here, the super fast test job, which has that empty needs keyword, which we just discussed. We will also go ahead and add the empty needs keyword here at the end of our test block. So go ahead, add that in here. Again, make sure that you have the indentation correct in here. If you're seeing that red underline underneath it, or if you're running into any issues, one thing that you can always do, as mentioned previously, is just click on that copy button and replace the entire test job in here. And that means that the syntax should be fine. Now, what we can go ahead and do is commit our changes. And then we'll go ahead and take a look at that pipeline that we just kicked off. So what I'll do here, again, validating up top, pipeline syntax is correct. So I'll go ahead and commit those changes. And now I'll go ahead and take a look at that pipeline. So easiest way of doing that, if it's not showing up here already, is just go ahead and click under build, click on pipelines, and then click on that link with the unique ID. And now, sure enough, we can see we have the build job running, but we also have the super fast test and the test job running here as well. Because we have that empty needs keyword here, they are going to all run in parallel, and the test jobs are not going to wait for the build jobs to complete. All right, let's see here. Step 2, directed acyclic graphs. All right. Now, let's see here. What if we had many stages and relationships between the jobs that we wanted to run as soon as possible? So the way we can do this is by using DAGs, or directed acyclic graphs. And what we're going to do first is we're going to make some changes again in our pipeline. So again, we'll go to build and then pipeline editor. And the first thing that we're going to do here is we are going to add a race stage in here. So we won't be completing a fully fleshed out DAG in this workshop, but we'll be creating a DAG race. So as mentioned here, we're adding that race stage. Just go ahead and copy the whole thing and replace the stage or the stages in here. So we can see we still have that build stage, we still have the test stage, but now we have the race stage. And now we are going to add a bunch of additional jobs in here. So we'll go ahead and copy these in here. And we'll see why in just a second. Copy those, paste those under the super fast job. And sure enough, we can see that all these different jobs in here leverage the needs keyword and show that dependence. Now, what we're going to do is click the Visualize tab to see how many stages there are and how complex this is. So if we click on this, we can see all these different dependencies in here, which is also really helpful to kind of identify where what is and what kind of dependencies are there. And so far, this looks good to us. So we'll go ahead and click on the Edit tab and then click on the Commit Changes. And now we'll take one last look at our pipeline. So again, we can go there via Build and Pipelines, or by clicking the View Pipeline button on the top if that shows up. And sure enough, we can see that all of these were kicked off right now. We have various different builds starting here. And then sure enough, we'll have these dependencies. So test car A will be dependent on build car A, and race car A will also be dependent on test car A. So we're basically, as the name suggests, racing these different jobs here, right? All right. So let's see here. Yeah, I think that's basically it with step 2. And so with that, we're heading over to lap 3, but that ends my section for today. So I will be handing over to Sujivan.
All right, I think we should let the others take like 10 minutes to either complete the steps and or take a break.
Yep.
So
Yeah,
let's say we will continue in 10 minutes. So at 45, 2:45. This is
sounds good.
let me create a short, quick 10-minute waiting time.
Nice. Were you going to share the screen and show
Yeah,
that typical 10-minute YouTube video timer?
exactly.
Awesome. All right, cool.
All right. So let's continue with lab number 3. I hope everyone is back from the short break and have finished their to-dos from the instructions. So let's continue with caching rules and failures. So this one is especially interesting, especially the rules part, and that can be a bit confusing. So let's see and hope on. Let's see how those works and what the benefits of those are. Afterwards, we will talk about templates and artifacts, child and dynamic pipelines, and that will also conclude the workshop itself. All right, so let's go on lab number 3. Um, welcome back first, and let's see on how we can make the pipeline faster and more resilient. So ideally, you probably as a developer want to develop things and want to build and test all your changes pretty quickly. And one thing can be the caching mechanism in GitLab. So what happens under the hood, first of all? So you can cache changes uh, in your pipeline, and those one will be cached by the runner itself and will be stored in the backend. This can be, as in this example, an S3 bucket, but this doesn't have to be an S3 bucket. It all depends on how your infrastructure is working and depending on if it's on gitlab.com or not. However, for now, we will focus on how you can use and leverage these kind of features, especially the caching part. So let's look on what's happening over here. So let's see. This pipeline has 2 stages, build and test, has a default configuration for the jobs, and 2 jobs specified as well, job A and job B. One of them is in stage build and job B is in stage test. As I said, this one is the default configuration basically for the whole pipeline, so for all jobs. And this is where we have configured the cache mechanism, including a before script as well. The jobs itself has, well, a normal script, an alpha script, or in this case, just a normal script. So now it would be interesting to see on what's actually happening here. So first of all, the pipeline starts and then job A starts. Why job A? Because first the build stage was running and afterwards the test stage. So first of all, the build stage with job A is running. But as we have configured this cache over here with a key and a path, in this job, it will use and extract the cache. However, this will only work if a cache has been found. So there might be cases where there's no cache defined or where the cache is empty, basically. Then it will not fail, but just build up the same content and will just use it as it isn't there. If it is there, it will be used. So this is when the before script is being executed, then the normal script is being executed. Afterwards, the after script is being executed. And then when the job concludes, the cache runs and this path vendor will be zipped and cached into the caching and saved into the runner settings using the key which was defined over here. That concludes basically job A, and then we'll go over to job B. So the job B will start. It will also extract the cache if it's available. In that case, it should be. The before script is being run, then the script is being done, and then the pipeline finishes as well. This is a really simple example on how the cache works and on how you can leverage it. So you may wonder now, why should you use a cache? So first of all, it's about that you can share downloaded content between jobs. So you may have files and artifacts which have been which you need to use in your several branches. So in that case, a cache can be used even across branches of your code. So you only need to download third-party dependencies, for example, once to that, especially to that specific GitLab runner where the job is running, and that will be being copied to your workplace in that job. You don't need to store the code dependencies itself, but it will just download every time when it's not available. And so when it's already there and downloaded, it will increase the pipeline speed. If it's not there, nothing much changes. So best case is your pipeline gets a little bit quicker. However, there might be some caveats as you need to build the cache. The cache also needs to be published internally in the backend as well. But yeah, in the end, there's always some things you need to take care of, or at least be aware of what's happening in the background. You may wonder what the cache is, or when you should use a cache, or when you should use an artifact. So the concept, they may overlap, because in the end, it's all about sharing content between jobs. But when you look a bit closer, you will realize they are a bit different. So what are the differences? So a job generally isn't reliant on another job's outcome, but it could be sped up by having access to them. So then use and cache if it's all speeding up and having access to them. It's not, you shouldn't be reliant, the cache shouldn't be reliant on the job. So if you really need an artifact from a different job, then you should use artifacts because otherwise it will fail. And so if you really want to use them, like using a build artifact, building a artifact in one job and then using that very same artifact in the next job, then you should use an artifact and not a cache. This is, and yeah, if you're looking for a simple sentence on how you can remember is, you can look into the sentence over at the bottom. So cache is here to speed up your job, but it may not exist. So don't rely on it. There are many more details. You can also click onto this link. I think the link to the slides have been shared, but you can also look into it afterwards on all the details about how caches and artifacts work. Another thing in this lab number 3 is job failure. This is rather simple, I would say, because there might be cases where you want to make sure that the job runs, but it doesn't matter that much if it has been failing. Normally, if a job fails, then also the pipeline has failed. But sometimes we have something like flaky tests, which you ideally don't have, or performance tests or something like that, where it's okay if it occasionally fails. So in that case, you can configure allow failure true on a specific job, as you can see over here. And then it will not prevent other jobs from executing. It will just behave like, okay, this has failed. It's okay. Let's continue with the rest of it. But again, it really depends on the specific use case. So be sure to only use it when it's useful. If you're running normal tests, it's mostly not really useful to allow failures, but you should probably know better on when it makes sense and when it doesn't make sense. The next thing, and this is where it can get a little bit complicated, and where most likely you will have some questions, because I'm always a little bit confused on that one as well. So the rules can be a little bit confusing at first, and you need to get used to it and how those works. In general, we have 3 different things we need to look at. One are clauses, so if or changes or exists. We'll come to some examples in a bit. We do have operators available for the variables to compare them using equals, not equal, and logical and or as well. And some other job attributes like when and allow failure. We have been, I've shown you allow failure in the previous slide. And when we look into the when options, we do have several other options as well, which we can configure. And I will come back to that. Well, I will come back to those in a little bit. So what is a rule? So let's look into this example first. So this is a job named job, which it has a script executing hello rules basically, or an echo for hello rules. And we do have 3 different rules defined. Before we look into the details of these rules, let's look into what's actually happening. So a job is not included in the pipeline if none of the rules defined for the job evaluates to true. So it's basically looking from top to bottom. If any of those rules are true, if none of these rules are true, it will not include this specific job to the pipeline. If one rule evaluates to true, but has the clause of when never, like this one, you will see, and this is a bit confusing as well. At least I'm always confused, or I can especially understand if you are confused as well. This one will also lead to not executing this job. And third point over here, if there are no rules defined, but when never clause is specified, then it was also not one. So as I said, this can be a bit confusing, but if you look into the specific example, it probably will make sense for you as well. So if you look into these rules, you can see the first one is comparing the variable CI pipeline source with merge request event, and the second rule is with schedule. And in that case, it should not run. So why is that the case? You may have merge request branches or scheduled pipelines, which you can configure in GitLab in general. And if that is the case, then it should not be run. This job should not be run. And this is when never can be useful. And if not, when on success, this would just execute it if everything else is not happening. So if it's just a normal branch pipeline, for example, then this job will execute. But if the pipeline is running as a merge request pipeline or as a schedule pipeline, this job will not execute. There are many, many more examples on rules. This can get really complicated depending on your use case. So be sure to properly understand on what's happening. And as mentioned before, it will go from the first to the bottom, and then we'll determine if it will be running or not. And there will be some more examples coming up in a little bit as well. So this is another example with where we don't use a rule yet, but this one is basically I mean, we did cover allow failure before, but sometimes it also makes sense to use when manual. In that case, that job will not run automatically, but it will run when someone presses the play button over here. This can make sense, for example, for deployments. So in that case, the deployment should be done manually, but you don't want to run anything manual otherwise, but just press the button. You can, in that case, also configure something like who can run the deployment and who cannot. But in the end, you need to configure the when manual part in your job, and then it will be a manual job as one example on how you can configure manual executions. But let's go back to the rules. So this is another example. And so what's happening over here? So this one is the job named Docker build. And what's happening here is the script is being run, so which is basically building a container image using the current commit tag, commit hash as a tag. And however, there's one rule defined, so it should only be done if the commit branch is master, so it should not run on any other branch. It should also be delayed for whatever reason, and it should start 3 hours afterwards. So if you commit something now on the master branch, for example, you are merging a change via a merge request, the pipeline is running on the master branch, it will not build this job right away, but it will wait 3 hours basically before it's being run. However, this also allow failure is configured, so it can still fail, but the pipeline still succeeds. If you need it, then you can use the start in part, but if you don't need it, then I wouldn't necessarily use it. So there might be some use cases where it makes sense. As always, just check the GitLab documentation if you want to know more details and can maybe also see some of the use cases and when you should use it. There are many, many more. It's a bit hard to cover everything over here. So be sure to always look into the documentation if you have more questions in there. So let's look into another example. Another rules example. In that case, we are using both if and changes. So what's happening over here? We are building a container image again, using the commit hash as a tag name. But in that case, there's an if for variable string value. So in that case, you would need to have the variable defined, this variable called var defined in either your pipeline or the project in general, and it needs to have the value string value. If that is the case, and when changes are made to the Docker file itself or to files in Docker/scripts/ in the directory, basically. If that is the case, then this will add a manual job to your pipeline. If that is not the case, then it will also not include in the pipeline, and in that case, not even as a manual job. You could, in the end, add an whenever to the pipeline, but that would be redundant. Just looking into the previous rule on how they are defined as well. As I said, this can be a bit tricky, especially if you're adding multiple rules. This is just one rule with multiple conditions. And then it can be a little bit tricky to determine, like, okay, when has this one, should this one, or shouldn't this one? So I can only recommend keep your pipelines as simple as possible. There are many use cases why it makes sense to do this, but also some cases, a lot of examples why you shouldn't do this specifically. In the end, it's up to you, but please bear in mind that keep things simple and stupid, just for your own sake. Okay, let's go to the issue number 3. I will go to my project now. So let's look on what's happening here. Let me go also to my project. Oops. And in that case, let's see on what the instructions are. So in this challenge, we will take your existing pipeline and modify it to show you how useful GitLab rules and allow failure keyword can be. So let's look into the first step. First, we need to reset your existing pipeline from previous track and remove all temporary DAG jobs. Make sure you're still in the workshop project. In this case, I am still in it. And use this left-hand navigation menu to click to build and pipeline editor so we can edit our pipeline YAML file. I will do that now. So I will click on build and pipeline editor. And my pipeline here is a little bit different now since I've not been following all the previous steps. But what is saying here? So in that case, remove all code that matches the code block below. Everything else can stay as it is. If you want to take it a little bit easier, you could also just copy paste this part, because this is basically the part on to ensure that we are at the very same point right now. All right. Let's see, pipeline syntax is correct. And now, before I commit, I will add some rules over here as well. So we will look first into this test job over here. So not the super fast test. And let's say we only care about this job running. Let's say we only care about this job running if it's being merged into main. So only when we do it on the main branch, which is in our case also the default branch, this should be added. Otherwise, it should not run. So to do this, you can add this rather simple rule. I will also copy paste this here and we'll add this as a rule at the bottom. As you can see now, this CI configuration is invalid because the job rules config should either be a script or a trigger keyword. This is because the indentation is not correct. And once I fix it, so the rules should be at the same level as stage, image, script, and so on. And in that case, the syntax is all right. So what's happening now, as I mentioned, if the pipeline which is being run is happening on the default branch, that is why we're using the CI commit branch variable, which is predefined, and comparing it to the CI default branch. If that is true, then this job will be added. So it will only be added to the pipeline if it's on the main branch, which is the default branch here. Otherwise, it will not be added to the pipeline, and only the super fast test job will run. However, we don't want to commit it yet, because we want to add in cache and allow failure keyword in the next steps as well. This is basically step 1. So let's keep moving to step 2. So let's see on what the next task is. We saw that after committing our last change, that the pipeline does take some time to run. Our next few pipelines will build off of our current configuration. So why don't we add some caching to the vendor Ruby and gemlog file so that they don't have to be pulled next time? Let's go ahead and add the code below under our image definition so that our node modules will be cached. So let's see, the image configuration is over here on line 1. And we want to add the cache on the global level, basically. And in that case, it will be over here. So for every job in this pipeline, the cache will be configured to be used. Is the pipeline syntax correct? Yes. And now that this code is added to the shared runners, it will cache this information in GCP cloud storage, in this example, especially since we're on gitlab.com, and will be pulled next time we run the pipeline. Before committing, we will complete the next step. So let's see on what's happening in step number 3. Let's continue right away. So what if our super fast test job, which is this one, had a job failing? So let's replace the existing script with a new one to make it fail. So let's use this one. And the script will be a bit different now. Let me fix the indentation. This should be right. Yeah. So as you may know, if you run exit1 in your pipeline, it will just be a failure. And in that case, it will figure it out. It will see it as a failure. We are not done yet because we want to make sure that this also has a specific rule attached to it. So first of all, it should only fail if it's on the default branch. So let's add it over here as an, oops. Let's fix the indentation. Oh yeah, I forgot the rules. Keyword. All right, now it should be fine. Okay, so what's happening now is, so if I am on the commit branch is equals the default branch, so in that case the master branch, then allow failure is set to true on That means that on feature branches, so if I'm not on the main branch, this is not the case. So it will not be added to the job as well. So the pipeline will be a bit shorter. So in the end, it should look like this. I've already done it over here. So we can go ahead and commit our changes and then can have a look into the pipeline. So let's commit it. And I will go back to the pipelines. So there is this pipeline running. And in that case, you can see the build job running, and then both test jobs, super fast test and test. I want to show you a little bit different thing. So what happens if I create then a new branch? So I will go to, where is it? A branch on code branches. I will create a new branch now. Let's call it testing rules. And I will create a new branch over here just to show you on how that looks, how the difference looks like. And in that case, since we've configured these rules, the jobs test and superfast test are not running because both rules in this example evaluate to false. And that means those jobs will not be added to this pipeline. So everything as we have expected it. Let's go back to the pipelines, to this one, I believe. Yeah, so this is where you can see that the pipeline has failed, which is not surprising because we have one exit one, and that means it basically fails. The test job, the build job, and the test job are still running, which is fine. Okay, I think that should be it. Let me see. Now it's completed. So in that case, it took, let's see if it's accurate. It took, 90 seconds, or 1 minute, 30 seconds to run this pipeline in fully. So we will add some more stages moving forward, but for now it should be fine. Okay, I will go back to the slides now, and after the next lab, when we finished talking about templates and artifacts, I will give you some more time to test things as well before we wrap it up. Or before we switch to the child and dynamic pipelines, and then we basically wrap up this workshop. All right. So you have hopefully fixed the pipeline to run smoothly again, so it will be a bit faster now. And now you want to make sure that you're using all the different features GitLab is offering, especially regarding security and artifacts. And you should be able to show this pipeline in the next stand-up. So what does that mean? So ideally, you want to make sure that you only define one job once and can be reused. And we nowadays have two different ways on how you can not measure, but configure pipelines. I do see someone with a hand up. Please use the Q&A function in here in Zoom, and that will be answered maybe at the end as well, or just asynchronously during this call. So what is a template? So there are basically three things to look into. So we want to make sure that the CI/CD capabilities within your team and with other teams in your organization can be shared and consumed, basically, so that you only need to define it once, either for your team, as I mentioned, to share it, or from other teams as well to consume it in your organization. And we, as in GitLab, we also provide capabilities via those templates, which you can use. and which we will show you in a little bit, looking into the mostly to the security templates. In the end, those templates are not magical. They are just normal, regular GitLab CI YAML files, as you can write it as well, and that can be used and imported and included in your projects as well. And they are always executed through an include in your project. We will show it. I will show that in a little bit. And those templates are created in your pipeline, and you need to have the stages defined, and also the rules which are configured in those specific jobs will be evaluated as well. So let's look into one example. So we do have SAST as in this case. What is SAST, you may wonder? So SAST is static application security testing. So basically testing your security for your projects as well. So that would mean that if you have, for example, a Java project, it will look into this Java project and we will see that you are using, or if you have any vulnerabilities in your code, which would, for example, lead to SQL injection, for example. If that is the case, these scanners will run and will determine and show you like, hey, you have the security vulnerability in there. This is probably not a good idea, so you should probably fix it. In this case, we are using Zemgrep in the backend. So we provide this SAST template, including specific rules maintained by us, so by GitLab's engineering team. And we'll make sure that you have the easiest job in terms of you only include this template, and we will manage to do everything for you. So automatically determine which programming language you're using, what SAST runner should be run, SAST scanner should be run to analyze your whole project to find potential security vulnerabilities. This is part of GitLab Ultimate, and you can just include it in your pipeline. So in your workshop project, you can include it as well, and that's what we're going to do in a bit. Some customizations will be done through extents and CI variables, but I will come to that one in a little bit. Basically, there are 4 different ways on how to include templates. So if you look into the top left one, this one is one example on how GitLab's engineering team provides some templates. So the previous example showed SAST as in one example. This one is using the code quality one, so that you can run code quality scans on your project. But this one is, as mentioned, coming from GitLab directly. It is in your instance already, and you can be using it. The others are a little bit different. So in that case, you could also say like, okay, I want to include a file from a different project. And in that case, it will check into the my group, my project project itself for a specific file, which is configured over here. And if that one exists and you have access to that one, it will just include this template file into your current pipeline and will execute it as you would normally. This can be in a different group, in a different project. It can also be local. So in that case, it will just be one include from a local file, so on the same project. Which makes sense if you have, I've seen CI templates, so GitLab CI files, which has like hundreds or multiple hundreds or even thousands of lines. And that is not necessarily always nice in terms of maintaining it. So in that case, it makes sense to split it up in separate files and then include it in your central GitLab CI YAML file in your project and use the local includes to include it. The other one is the remote one, so you don't necessarily need to use the same GitLab CI template file from the same project. You could also just pull it from a different place, which can be a remote file wherever you want it to be. So in that case, it can also be something on the public internet. Templates are just one example on how you can do something. Templates are also the older one on how you can run and reuse CI bits and pieces. We do have something new available as well, which are CI/CD components. And CI/CD components are are like the next generation CI templates. So they are released like a true app with the versioning. So you can specify something like, okay, which version do I want to use? You can also do that with templates. But the point is that you don't need to reinvent the wheel and have proper that you can properly test it and can also use some input parameters more directly and in a better way. And we also want to make sure that the discoverability are a bit better, not just from GitLab, but in general. And this is what CI/CD components are for. This is still pretty new. And this is why we just started with the CI/CD catalog. So in that case, you could use and leverage existing CI/CD components instead of templates, for example, to find your use cases, what you might need. For example, you want what is it over here? Secret detection. In that case, you can just use this not this template, but this component from GitLab.com rather than invent your own tooling and pipeline. All right. Let's look into the options for customizing job behavior. So as I mentioned, you can just include certain YAML files in different ways, and you can just extend it in different ways. And so in that case, you can configure something like environment variables, which can change the behavior. But that always depends on how you can configure these YAML files in your project. Oops. Yeah, so going over to the next thing. So if you are running, apart from running security scanners out of your code base, we also want to make sure that your pipelines are safe or secure in general. So you can use CI/CD variables for it, but be sure that you are careful on how you store sensitive information in your project. So depending on your permissions, you may be able to mask to see and configure variables, including secrets. But you can always mask and protect those variables so that you can also use including tools like HashiCorp Vault for any high risk secrets, so that you cannot really export it in the pipeline. Variables can be a little bit confusing as well, because you can define variables in so many different places. And depending on which place you configure them, there's a different way on how and which one will override which variable. So this is the order of the precedence for variable. So from highest to lowest. So let's go to the lowest one. So what you can do is you can configure predefined environment variables. You can have deployment variables. You can have global variables, but you can also have job level variables. So if you define some variable over here, well, it is already predefined basically, you can still override it as a global variable. And that one can still be overwritten by a job level variable. This can get a little bit complicated, so be sure to only make use of the variables where it makes sense, because those can be inherited as well. There can be instance level variables, which could also be protected variables depending on the branches, also on the group level. So it really, really depends on where and how you define the variables. I would recommend to don't make it too complicated as always, so keep it simple as much as possible. And in that case, it should be if if a variable is only relevant for a specific job, for example, and not outside of this job, only define it on that specific job, so it will not be cluttered and it will not be confusing. But I could basically talk 1 hour about it, so I'll keep this one short for now. So the next thing is about artifacts. We covered artifacts quickly when we talked about caches. And the thing about artifacts is that you can download this using your browser as well. And which is this download button in if you have running a specific pipeline job. What you can also configure is an expiration date. So let's say like, okay, this artifact should only be there for 1 hour basically, on how long you want to keep this artifact. But if you want to keep it longer, then you can still override it basically by clicking the keep button over here. And in that case, the artifact will stay there. If it should be kept indefinitely, basically, don't use an artifact, push it to to a package registry, for example. So be sure to only use it where it makes sense, because you shouldn't keep job artifacts in general for a long time anyway. Because if you would want to keep something more longer, some people do that using Jenkins, as I've seen in the past a lot. Don't copy the same thing. Use the proper artifact storage, either in GitLab, for example, by using and leveraging the GitLab package registry for that as well. As I mentioned, you can download the artifacts on different places. So it can be on a specific job, as shown over here. It can be download from the pipelines page. It can also be download from the job page, and where you can also browse the different artifacts in that job to download it and yeah, look into those artifacts as well. Okay, let's go to the fourth task, which are templates and artifacts. So let's go to this issues again. And I would now rather say you could probably do that on your own now. So I will give you about 10 minutes to so that you can go through these steps. And I will after that come back and will show you on how that will look like when I do this. So that would mean I will put up a timer again, and the timer is running. So, and then we will continue. So if you are finished with your tasks, so basically task 3 and 4, then I will go over it in 9 minutes 45 seconds. So see you in a bit. All right, let's continue with step number 4. Or task number 4 with step 1. So there are two things. Let's look into the steps first. I hope you all done it already, so you can follow along. I will give you a little bit more insights on what's happening over here as well. So first we have this root cause analysis, then we are preparing the pipeline for the security scanners, and then we are also quickly checking out CI/CD components before we look into the further steps on how you can use inheritance to enhance your pipeline and how you can store your artifacts. Let's go and look into the first one, so the root cause analysis. So as you may have seen, this pipeline, and well, as we have been covering it, this pipeline job has been failed. So the super fast test job, and at the top of the job, you do see of the job log, you do see this troubleshoot button. So let's click on it. So what is this? So as you can see here, this is one of our AI features, which is basically saying like, okay, this will be run through our AI tooling. This is an experiment as well. So basically it's using an AI system in the backend to determine on what's happening here and why this is failing. So this job failed because the step script stage of this job executed the command exit1, which causes the script to exit with a non-zero exit code, indicating an error. To fix it, just don't use exit1, and then it should work. So this is one example on how we leverage our AI features as well, in that case, to determine and see on what's happening here, and why it's failing in this case. In this example, it's pretty obvious, but still, there are probably a lot more features available where it isn't that easily found. If you're looking for this button on your self-managed GitLab installation, then you will not find it, because this one is for now gitlab.com only, and will be part of our AI offerings moving forward, as long as far as this one will not be experimental at a certain point anymore. Okay, so that was the root cause analysis for failing pipeline jobs. Let's go to step 2, preparing the pipeline. So we are back into our workshop project, and I will go back to my pipeline editor as well, and I will show you a few things which will make things easier. And I will also cover one question which came up in the Q&A section in Zoom, because someone was a bit confused, which I can certainly understand. So we are back in the pipeline editor. So let's include the SAST template. I will copy paste that here. Let's see if I have an include in this GitLab CI file in general. I do have some globally defined cache and images, service variables, stages, and a few jobs, but no includes. So in that case, I am including the GitLab provided security SaaS template. And as you can see here now, 2 new files popped up, because if I just remove it again, you can see it's only a GitLab CI YAML file, but in that case, the security SAST GitLab CI YAML file popped up, and the jobs SAST GitLab CI YAML file popped up as well. So since we have included the security SAST template, let's click on here. And this is where you can see this is basically including not doing much than including the jobs SAST GitLab CI template. So I can also click over here as well and see a pretty long GitLab CI template for SAST. So what I can also do, instead of going through security SAST, I can also just include the jobs SaaS GitLab CI template directly, because the other one was the older one, which is now deprecated and just for yeah, basically done in one place. So in that case, you only need to have jobs SaaS GitLab CI YAML file included. What's always interesting to use especially when working with templates, doesn't matter if it's GitLab templates or your own templates, we do have this full configuration button over here in the GitLab CI in the pipeline editor. And this is where you can see basically the whole pipeline merged together in a single file and to see everything what's happening here. So when I scroll down, I will showcase you one thing, for example. Where is the semgrep one? Let me search for it. So we do have the semgrep SaaS job defined. It has been configuring some artifacts, but it's also configuring some rules. So let's look into some real life examples for rules. So in that case, there's a rule named SaaS disabled is true or disabled is 1, basically. So if you configure that, SaaS will not run. If you if you define a variable SaaS excluded analyzers and put in semgrep in there, it will also not execute this job. But what it's also doing is it is checking the commit branch basically for all the different file types in your projects and will then run the semgrep analyzer for you. So if you, for example, don't have any Java code in your project or just, let's say, a README file, then the semgrep run will not run, because when you look into the visualized one, you will see a lot of security jobs being added here. But due to the rules, it will not run in every project because you may not have MobSF, Android, or iOS projects in your project included. So it's rather not super intelligent, but it will only include those tests and jobs which you really need. Okay. When I think we did that already. Full configuration one. Okay, so I will copy the whole thing now. So SaaS is just one example. We also have code quality, dependency scanning, and secret detection, and a few more security scanners available. If I look now into the full configuration, you can see these are nearly 700 lines of code. So this is quite some much. And you really don't want to reinvent the wheel every time. We do that for you. And so you don't need to configure everything on your own. And this is basically one of the values you'll get by leveraging our templates. Okay, I will I will not commit it yet because we are doing something in the next steps first. But you may have been already checking out the CI/CD components. I will do that now as well. Because I will click on OpenTofu, for example. So if you're using the Terraform fork OpenTofu, you could also use this component, which is in that case maintained by GitLab. And this is one example on how you could use it in your projects as well. So in that case, you also use the include part, but you would also use the component keyword, basically, followed by the definition on where it can be found. So in that case, it's gitlab.com using this URL basically. And you can configure some inputs as well. In that case, the version for the template and also the version of OpenTofu, and configure some more things. But this is all in this defined in this README file, basically. This is just one example. We won't go into more details here, but feel free to look into the CI/CD catalog, but also feel free to check out CI/CD components in general, but we will not cover it much deeper in this place or at this stage of the workshop. Okay, let's look into step 4. So let's use inheritance to enhance our pipelines. So first, navigate back to the tab with the pipeline editor open. I'm still in here. Now we'll create a new SaaS job that will override some of the functionality from the template we included. The below code sets up new code and has it run as soon as the pipelines begin. So in that case, I'm adding SaaS. We'll say like the state should be security. The default is test and not security. And we'll also say that the needs keyword is defined. And let's see. And now it will complain that the GitLab CI configuration is invalid because the SaaS job has a stage that does not exist, because available is pre-build, test, and post, and there's no security stage yet. So I will go ahead and add it over here as well. And now it should be correct. Yes, that is the case. And before committing the code, we are going to add the artifact keyword in the next step. So let's move on with the 5th step. So let's say a requirement comes in that we want to store the results of the build job in an artifact. Let's change the build to do that. I will just copy paste it. And then we'll then go into the details. So this is the build job. The build job is over here. Pipeline syntax is correct. So what's happening here? I'm configuring some variables. Oh, let's look over here because it's a bit wider. I will use a different with certain image name using predefined GitLab variables. I do have an before script where Docker info is running, but where I'm also logging into the GitLab registry using the registry user registry password variables. Then I will run the Docker image, the Docker build as a script. And in an after script, I will also push the Docker file to the GitLab internal CI registry. So the important part over here for the artifacts is that I want to save the gem file log as for 1 hour as an artifact. So I will now go ahead and commit the changes. And now I will go to the pipelines. So the pipeline is all running over here. So as you can see, I've configured security SaaS to run directly, because I did say that the needs, that I don't configure any needs. In that case, it will run directly right away. Okay, the pipeline is running. Let's see if I forgot anything here. If you got lost at any point, just merge the extended SaaS branch as well. Okay. Note that we have also added new stage. It continues to run through our super fast tests. Job is still failing. Exactly, it's still failing. We are then going to grab the build artifact that we specified in the pipeline. There are a few different ways to get them, but we are just going to use the left-hand menu to go through build pipelines, where the most recent pipeline that kicked you off should see a download icon, and then click on build archive. So in that case, this is this one to download the artifacts. It has not been fully run yet. That's why only the SemGrep artifacts are being listed. But since you are following, hopefully have been following on doing it on your own, you can download the artifacts over here. All right. This is all for step number 5 in issue number 4. We still have child pipelines and dynamic pipelines coming up. And this is what we will do now. So let's go back to the slides. Let's start. Let's continue with child pipelines. And then we will follow up with dynamic pipeline. These are pretty much related, so I will cover them one after another. And then we will, yeah, basically ending this workshop. So after you've tested, you're running the pipeline with your SaaS scanners enabled, that you have running your own pipelines with more scanners, and you may want to integrate it and into your pipeline. And there are different reasons on how you can do that. So that this example, you can just use a child pipeline to include other pipelines as a child pipeline. So first thing first is a downstream pipeline. So this is basically a multi-pipeline CI/CD setup. And this allows different kind of ownerships for different parts of the pipeline. So it really depends on your use case. Ideally, you don't need a downstream pipeline, you can do everything on your own, but you may be in some environments or regulation where it makes sense to have a different ownership of different parts of the pipeline. And these can be depending on your pipeline, and you can also generate YAML files from the parent pipeline to run it as downstream pipeline. These are the dynamic pipelines I will cover in a bit. So basically we have two types of pipelines. One is the parent-child pipeline, and the other one is a multi-project pipeline. Let's focus first on the parent-child pipeline. So the pipeline generally exists in the same project, and they share the same project reference and commit SHA basically as a parent pipeline. And they do not directly affect the overall status of the ref of the pipeline once again. So the ref is basically like the commit message, not the commit message, the commit ID in your project. However, you can only have at maximum 2 child pipelines. So one parent child pipeline and another child pipeline, and that one can still have one child pipeline. The other one is multi-project pipeline, and those can exist in different projects. So in that case, one upstream pipeline is basically the triggering pipeline, and that does not have much control over the downstream triggered pipeline. So basically having one upstream pipeline in one project and saying, like, okay, I want to trigger a different one, and that one is then the downstream pipeline. And those are pretty independent. So there's no nesting limits. So you can have a complete chain of pipelines triggering other pipelines. You can also can get creative at least, and can run child pipelines and so you can configure rules and child pipelines together. However, this can be a bit complicated as well. As you can see here on as an example. So we do have 3 different jobs defined: job 1, job 2, job 3. The first job is basically has a rule like if the pipeline source is pipeline, then it should run basically. And basically echoing this job runs in multi-project pipelines only. We do have job 2, which will only run in merge request pipelines. This is why the rule is there. And then we have job 3, which have 2 rules, basically pipeline and merge request event. And this one will run in both multi-project and merge request pipelines. This is just one example how you can configure and make things sometimes a little bit more complicated. You may need to, but this is just one example on how you could configure it. You can also configure so-called workflow rules as well. So one thing is the auto cancel pipeline. So as soon as one job fails, it cancels the whole pipeline. This is especially useful if you have results which are depending on other parts of the pipeline, and will save some time, because if something fails, then you can just configure it to fail in general, or auto cancel the whole pipeline in general. So let's jump right into the instructions. I will do that now directly right away. So let's go into the child pipelines. So we do have step 1, preparing the child pipelines, step 2, linking the pipeline, and yeah, basically 2 steps. So let's go into the details. So as I mentioned, your security team got wind of all the security scanning you added to your pipeline. And once it to be added to a new pipeline that they have access to and can control which jobs are run. To do this, we are going to create a child pipeline that we can link from our existing pipeline. In this case, we will just be adding the second pipeline to this project. Could have been added in a separate project and then be linked. So let's use now to create this pipeline. We will first want to click the name of the project. I will do that now. And then click Edit and Web IDE. This will just use the GitLab internal Web IDE, which is basically a Visual Studio Code in your browser, having already checked out your whole project, so you don't need to go and do something locally. So what does it say? So once in the IDE at the top level of the project, we want to create a new folder and call it security pipeline. So let's do that. Right click new folder, security pipeline. I created this folder now, and now copy and paste the code into a new pipeline config below. Notice that most of it is pulled from the existing pipeline we have been working on throughout the workshop. All right, so let's copy paste this one. And where is it? Over there. New, oops, new file. GitLab, let's call it just GitLab CI YAML file and save it. Okay. So this pipeline now has all it needs to run our security tests. Once added, click the source control button on the left-hand side to add a quick commit message, then click commit to main. Once done, a pop-up will appear and you want to click back to go to project. So let's go to this Git button and I will just say edit security pipeline GitLab CI YAML. Commit to main. I will do that right to main. And this is where this button pops up, go to project. And the pipeline is running now. But I do want to go back to the pipeline editor now because I did not link it yet. The pipeline is running, but yeah, I didn't add it yet. So this is where step 2 comes in place. So first we are going to remove all the duplicated code in existing pipelines. The code below will be our existing pipeline minus everything the security pipeline now covers. I will copy that one and just paste it over here. And now we want to make sure that we're adding a new stage for the child pipeline. So this is basically the stage extra security. I will do that now, extra security. And let's also add a job that calls the child pipeline in the security stage. And this is basically the interesting part because now I am adding a new job called downstream security. This is the job name and the stage name is extra security, which I included or set it up over here. And I am using the trigger keyword, but I'm including a local pipeline. I don't think I need that much of indentation over here. Is the pipeline syntax correct? Yes. So now I can commit the changes, which I'll do now. And we'll go back to the pipelines, which is now pending. Yes, and this is where I can see, okay, I still have the stages build test and now the new security, extra security stage. But this one has a job called trigger job, and this one is basically triggering the other job. As you may see, it's not popping up yet because I did see that I have a different name for this one. So I will go ahead and fix it because I named my file differently. This was not a good idea. So this was security pipeline GitLab CI YAML file. So I will go back to, oops. To pipeline editor. and we'll just name it GitLab CI YAML file in the security pipelines. Pipeline is running again. And yeah, now it's fixed. However, the pipeline is waiting for these jobs to run. And then you will see on how that looks like. Maybe the other one has already failed. Let's see. Not yet, because the tests are still running. It will take some time, which is fine. And this is basically the first, well, the instruction issue number 5. And we will further continue with lab number 6. Yeah, and then I will give you some time to check it out on your own. So let's go to the dynamic pipelines. And this one is a little bit different. So in that case, your security team loves to see that they can manage all of the security scans in a downstream pipeline, but they also ask if it's possible to generate their own security scans through code. You decide to create another demo to showcase the dynamic pipeline feature GitLab has to offer. So what are dynamic child pipelines? So generally, you can trigger a pipeline from a YAML file that was generated by another job. That is a bit interesting, I would say, because depending on your use case, you can generate or create a dynamic workflow to react to the content changes based on your pipeline, and that will then build the pipeline for you. So let's go into the details. Or one example, basically. And this is where you can see on the left-hand side one script which is running. So this one will generate, this can be a script in whatever language you want to. And this one can generate, in this case, a YAML file named generated config YAML file. You need to configure it as an artifact so that this file is being stored as an artifact. And then you can trigger it as a downstream pipeline or child pipeline in a separate job. And this YAML file will be stored as an artifact up to 5 MB. I don't think you want 5 MB of a generated config file, because that one will be a very huge job. And so one example where this might make sense. So I did see that from different customers, this specific one where they are dynamically creating child pipelines. In that case, they have like a really long list of several directories, and they didn't want to hard code every directory, but the structure of every directory was pretty much the same. So but they were always or regularly adding new directories to your project, or sometimes also removing some directories, having some projects file included. So what they did is they wrote a script which generated a config file just similar to this one. So for every directory, it created a job in that YAML file, and that one generated and then run it as a child pipeline. So the burden to maintain it was pretty small. And this is where we go to the workshop instructions, to the last bit, basically. Let me go back to that one. So let's look into the dynamic pipelines, issue number 6. Oh yeah, this is now where you can also see that the downstream pipeline has failed, but this one was because I was using it incorrectly. And this one has run properly, or is still running. So as I mentioned, this is the downstream pipeline being triggered, and this is where the tests are running in a downstream pipeline. I can also go back to the mainstream pipeline by this, and this is how you could see how that looks like. So this is a parent pipeline triggering the downstream pipeline, which is now running as well. Okay, so let's go back to dynamic pipelines. And this is where we also need to go back to the web IDE. So let's go to the web IDE again. I can close this one. And I will create a new file called pipeline YAML creation. I will copy this one. So let's create a new file named pipeline YAML creation.sh, where I copy paste this file. And we will then use source commit to main. Yeah, okay. Add pipeline YAML creation.sh. I'm committing it now to main. And we'll go back to the project. So now we will go back to the pipeline editor. And this is where I will be changing the downstream security job. So I do have this one still in there. First thing, we want to delete the code below that called our downstream pipeline as we're moving that functionality to our dynamic pipeline. So I will be removing this one. Now remove the extra security stage as well, which is this one. And now I will copy paste this one into the job. Add a stage called dynamic. See if everything is fine. Pipeline syntax is correct. Let's go ahead and commit changes and use the left-hand menu to go back to the pipeline. So let's see on what's happening here now. So we did configure the dynamic security build job, which is using, well, first make the pipeline YAML creation shell script executable using shmod, and then basically run this file. And this one will create, if we go back to the IDE, this one will basically run and execute this example, basically the same one, and write it to a security config YAML file. And this one is then being saved as an artifact over here. And then we are using a dynamic security run, a dynamic child pipeline to run it, to trigger and include the artifact which we're using here. So referencing this one as well, and also defining the name of the job. And the strategies depend because we want to have a depending job. Otherwise, it can also be loosely coupled, basically. So let's view the pipeline. It's not run yet because it's still building. Let's see if I forgot something. No, so this one is still running. Let's see on how long that will take. Oh yeah, it's still building the container image. I will wait a little bit. This one is done now. Yeah. And this is how you can see that the dynamic child pipeline is successfully running. Okay, and that's basically it. Since those tasks in issue number 5 and 6 were a bit quicker and we're ending anyway, I would say that you can, or hope that you did that right away, because now we are basically at the end of the workshop and we are open for Q&A. Just one note, you can transfer your project because we want to make sure that if you want to continue something, you need to move this project to your own namespace on gitlab.com. Otherwise, because that group which was created will be deleted afterwards. I think it was 2 days, Logan. I'm not entirely sure.
2 days.
2 days. Okay, thank you, Logan. So in 2 days it will be deleted. Until that, you can still use that project in that specific group where you have all the features enabled, so all Ultimate features and the AI features as well, I believe. And after that, it will be deleted automatically, so you won't have access to it. You can still start your own trial if you want to have all the features of GitLab available for a month, but that will be visible in your account as well. So yeah, feel free to transfer the project. So what you need to do is you can go into your project and go to courses transfer project folder and look into this file called transfer markdown. And this one have all the instructions on how you can leverage or how you can transfer your project to your personal namespace, basically. All right, that's about it. That is basically the end. So you did see and hopefully understand on how you can use direct DAGs, execution orders of your pipeline, caching, as well as rules. My general advice is feel free to test out those rules if you haven't already in a more complex setup, just to see on how they work, how they feel like, what you can do with it. And feel free to also look into templates which are useful, or directly look into CI/CD components because they are new. And that's about it. I think we will switch to live Q&A now. So I will stop my screen sharing. Yeah.
And for live Q&A, we'll be looking at both the chat and QA sections. Just some general reminders before we jump into it. Post the end of this workshop, you will be sent a copy of the slide deck, the recording of this session, and then you do have those 2 days to mess around with the space. Like mentioned before, if you followed the redemption steps, your group has a Duo Enterprise license attached along with GitLab Ultimate. So you have access to all of our features running on the latest version of GitLab. So with that, we will jump into questions. First one being, in a merge request, if we use a child pipeline, does the status of the child pipeline affect the ability to merge the code?
In a merge request, if you use child pipeline, does the status of the child pipeline affects the ability to merge this code? Yes, but it depends on what you have configured on as a strategy. So because if you have said, let me go back to, no, I need to go back to this one basically. It's a good question. So where is my pipeline? So the strategy here is depend. So it's depending. In that case, the pipeline has not fully run. The main upstream pipeline has not fully run until all child pipelines have successfully run. In that case, it will affect the ability to merge the code if you have configured in your project only merge code when the pipeline has successfully run. I think there was also some other strategies in that case, like completely independent. In that case, it wouldn't matter, and then you could just continue merging even if the child pipeline is still running.
Sweet.
So
then the next question we have is, can you just briefly show in the project where to access the transfer steps?
Yes, so you have this project and there's this courses folder where there is a transfer project directory, and this is where transfer markdown is included. And this gives you all the details on how you can transfer your project to your personal namespace.
Awesome. And then I know with transferring the project, I can't remember if we do it, but you might have to clear out the container registry. It's pretty simple to do. It does take like 30 minutes because it's a timed job, but then once you do that, it's pretty easy to transfer from there. Additionally, you can do group transfer. There's only one project in the group, but you could just transfer out the group as well. So the question queue is empty. We'll give it a few seconds. I shouldn't say a few seconds, a few minutes before we go ahead and close out. Oh, we got another one. Can the parent pipeline push some changes in the child project and create a new pipeline with changes in the child project?
This would not work, I believe. Because
I think you could do it with a downstream pipeline, right, where it's two separate projects, but I don't believe you could do it with a parent-child on the same project. I'm trying to think if there's any use case where you could.
yeah, that should be possible, not in every case, but as you mentioned. Because in that case, you would script something to make a change in your secondary pipeline, basically, or secondary project, which would then itself probably trigger a pipeline as well.
And debatably, you probably rather use a dynamic pipeline. Like if you're going to be making some changes, you could have the dynamic pipeline generate your second piece based on results, using code, and then trigger it that way. That's probably the route I would go.
Yeah, but my other question would be like, why do you want to do that? Because in
Right.
many cases, like different ways on how you could achieve something. And in that case, it not necessarily makes sense to do it that way. But yeah, I don't know the details. I mean, many examples in this workshop have been hypothetical. So it really depends on what you really want to achieve. And I would say just try it, especially as a beginner, basically in this topic, because that one will also give you some more understanding of what works and what doesn't work.
You do have a follow-up response. You can repost.
Do we?
No, I was saying asker. The next question came in. If we have external integrations added, then would it be added to the child as well?
What are external integrations? I mean, we do have integrations in GitLab in general in projects with external projects, but that are not necessarily linked to the pipeline. You could
An example, sneak scanning integration.
okay. Yeah, you could do that, or you can just run it directly in the pipeline. So if you don't need child pipelines, then don't use it. So ideally, you just run it directly in the pipeline, I would say.
Or you could store the results as like an artifact and pass that, I guess. Not, I don't know what you would pass from the integration.
Yeah. Yeah. Okay.
Question came in. When I'm trying to transfer this project to my personal namespace, I get project cannot be transferred because tags are present in the container registry. That's what I was mentioning before. You can go ahead to the container registry and just delete the tags. It is a scheduled deletion, so it takes some time. But as long as the process is kicked off pre the 2-day mark, you should be fine.
Yeah, it's basically described in the document.
Yep. No problem. Next question. When we do integrate GitLab with Sneak, it directly adds the stages under external stage, and we don't have any control over the name or position of the stage. So wondering how it would behave in a child pipeline.
I don't really know. Do you know that? Because I'm not sure on what's coming from Sneak and whatnot.
I don't based on what I know about child pipelines, I don't think it would be like auto included. Like it would be something that you would have to re-include in the child pipeline. If how I know Sneak integrations are included, if that's still correct. I don't think the context would be passed. If anyone else on the GitLab team has a better answer, feel free to chime in. Or we can close it out.
No. On mine, I'm just looking at the integration itself, and yeah, it seems like it's a integration offered by Sneak itself. So not super familiar with it, to be honest. So I wouldn't be able to contribute more to that answer.
Hopefully that gives some extra context.
Okay, any more questions?
Lauren, I saw that you linked the issue, and I know we've been talking before. With that, I've reached out to your account team, so they should be in contact with next steps and how to talk it through.
All right, I think otherwise you can probably wrap it up.
Yeah, I think we're good to end. Thank you all for coming. As mentioned before, the recording, link to the slide deck, etc., will all be sent out in a follow-up email. If you're curious about more of these events, you can always go to gitlabevents.com. We tend to do around 3 of these a month on different topics. So definitely check it out. And thank you for coming.
Thank you. Goodbye.
Thanks. Bye, everyone.